We are going to work with some examples calculating some simple logarithms. Before we do that, though, I would like us to take some time and look at the notation of logarithms. We know that every time that we want to calculate a logarithm, usually the number will be given in this format. Log with base 2 of the number. And in order to find the logarithm, what we need to do is to rewrite the number inside the logarithm as a power of 2, or approximately, and the logarithm is going to be nothing else than the exponent 4. Okay, but we have some notation exceptions, and we want to make sure that we remember those. So whenever the base of the logarithm is e, we never write this as the expression for the logarithm. So log of e doesn't exist as notation, as a notation. It exists, of course, but instead of that, we write ln, that stands for natural logarithm. So whenever you see ln without any base right here, it means log with base e. Also, because we use the 10 number for our metric system and for our number system, the log with base 10 is simplified to be written as just log. So whenever you see no base under your log, then this means that the base is 10. So whenever I want to say, let's say, the log of 100, and I want to know what is the log of 100, then the log of 100, that is nothing else than log of 10 of 2, I assume, I never write it, that the base right here is 10. Okay, so whenever you see nothing in here, it means that the base is 10. So the answer for that would be the number 2. Okay, by knowing this, let's try and calculate some simple logarithms, or not so simple, depending. So the first thing that we want to calculate is the log of 1000. You can see that there is no base here, so immediately you assume that the base is 10. So you want to calculate the log of base 10 here. I don't write it, or maybe I should write it with a very light color so you remember. And what I want to do now is I want to rewrite the 1000 as a power of 10. And this is 10 to the third. So the logarithm for that would be nothing else than the exponent, so the answer is 3. Okay, so the same happens for this logarithm right here. The log of 0.01. Again, I have nothing down here, so I assume that the number that I have as my base is the number 10. Now, there is a small difficulty because I have a decimal number here. So the first thing that you need to do is change this decimal number into a fraction. And the fraction will be 1 over 100. Okay, so you have base 10 here of 1 over 100. Now, 1 over 100, remember, can be written as log of 1 over 100 can be written as a negative power, so 10 to the negative 2. Why is that? Remember, 10 to the negative 2 is nothing else than 1 over 10 to the second. What do I do if I have negative exponent? I bring it to the denominator with the positive power, and this is nothing else than 1 over 100. So I know that 1 over 100 is 10 to the negative 2. So the power here, the exponent here is negative 2, so my answer is negative 2. Okay, so this is the answer here, this is the answer here. Okay, good. Let me see. It's not gonna happen. Let me make sure that I connect those lines, and I have the negative 3, the 3, number 3 is here, and negative 2 is the solution for that one. Now, I'm looking at the log with base 4 of 1 over 64. Again, I want to write this as a power of 4. Again, this is at the denominator. 1 over 64 is the same as 1 over 4 to the third. But this is at the denominator, so I can bring it at the numerator as 4 to the negative 3. This is from the similar rule of negative exponents. So this is nothing else than log with base 4 of 4 to the negative 3. I can see now that my power is the same as the base of the power is the same as the base of the logarithm, so the result will be negative 3. And this is the result for this logarithm. I work in the same way for this logarithm. Now, this is a little bit confusing because I have the number 49 here and I have the number 7 here, and the 7 is smaller than 49. So what I need to do is to see if there is any power of 7 or any power of 49 that is 7. Well, this is not clear, but 7 is nothing else than the square root of 49. Do you agree? You agree? Okay, perfect. Now, how do I rewrite square roots or roots in general of numbers as exponents? These are rational exponents, as we name them. So since here the radical is in the number 2, this is the same as 49 to the 1/2. So 7 is equal to 49 to the 1/2. If I rewrite my logarithm, I have log with base 49 of 49 to the 1/2. The exponent is 1/2, so that's my answer, equals to the 1/2. Okay, so pretty much when you have when you have to calculate logarithms, you have to find the proper rules, either of negative exponents or of the radicals, in order to change the number that you are using into a number that appears as a power of the base. Now, let me review right here for you the rules for radicals. So if you have a number, any number, let's name it k, and let's put here 5, then the fifth root of k is nothing else than k to the 1/5. So what happens is that I keep the numerator to be 1 and the denominator will be nothing else than the order of the radical. So let's say the third power of the third root of 27 is going to be equal to 27 to the 1/3. Just to remind you how this works, what the rule says about the radicals. Okay, so let's move on to another example. Let's look at this example right here that is quite simple. Why? Because the argument of the logarithm is written already as a power of the base. So 8 is the base, 8 to the 25. What is my answer for that? Just 25. That's the answer for this because I have it already. So I don't need to do any work for this specific problem. And let's look at this one. This one, the log with base 27 of 3, is similar to the one above. So these two problems are similar. So they need to be solved in the same way. Again, 3 is smaller than 27, so I need to try to find if it can be written as a root of 27. Well, that's true. 3 is nothing else than 27, the third root of 27. Why? Because if you think about it, this is the third root of 27, because 27 is 3 to the third. Okay, 27 is 3 to the third, so you can simplify the 3 with the 3 here, and this is equal to 3. That's why the 3 is equal to that. Okay, so you replace here the number with the log with base 27 of nothing else than the root, the third root of 27. Now again, I have a root and I don't like roots. And how do I write it? Well, I'm going to use this right here, a rule that says that whenever I have a radical, a specific radical of a specific order, I can rewrite it as a rational exponent, where the rational exponent will be 1 over the order of the radical. So right here, this is nothing else than the log with base 27 of what? Of 27 to the 1/3. So this means that this log is nothing else than 1/3. That is the exponent of the 27 on my problem. Okay, so pretty much this is how I work, and let's work on the last two examples that I have here for you. That they are simple, but the only difference is that I have a special notation. Remember, the special notation says that whenever I have a log with base e, I don't write it as log with base b, I write it as ln right here. Okay, let's work on this. So the problem that I'm solving is the problem ln of 1 over third root of e. Okay, there are a lot of steps that we need to take here, so let's work those slowly. And the first step is that I have right here 1 over square root of e. So I don't like this, the third root of e. I want to rewrite it as a rational exponent, ln of 1 over e to the 1/3. Why? Because the radical order here is 3. Okay, so that's the first step. But again, now the e is at the denominator. I don't like it at the denominator, so I need to bring it at the numerator with a negative exponent, e to the negative 1/3. Okay. So now I have the logarithm with base e of e to the negative 1/3. So the solution for this, it will be negative 1/3. And that's my answer for this problem. Okay, yeah, it has a lot of steps, but if you go slowly, the one after the other, there are no issues. Remember, the two properties that you need to remember, the properties how to translate radicals and the property of how to translate negative exponents. And the last one, that is quite simple, because I have ln, so log with base e, of 1. But we remember the rule that the log of 1, no matter what the base is going to be equal to 0. Because e to the 0, basically what I have right here is e to the 0. That's equal to 1. And the exponent is 0. That's why my final answer for that will be just 0. And at this point, we have completed quite a few problems. I hope that you stayed with me throughout the presentation of those problems. And we can continue with more problems in class.